Hi everyone, and welcome to this new class in engine propulsion and specifically the design of compressors. Okay, so first thing we need to know is that compressors are used in all cases, okay, as a noun, as the same name, okay, introduces, to actually compress the flow. And this means increasing the pressure of the flow. Now this is the first stage that we encounter after the inlet. Okay, and the idea is to get the flow to a very high pressure state. Now, mechanical work on the flow, okay, results in the increase of pressure. So the idea is that the compressor is actually moving at very high speeds, and these high speeds allow the flow or force the flow, okay, to go from a low pressure state to a higher pressure state throughout all of these stages. Okay, so imagine that the flow is coming this way, and actually the flow is rotated in this way, and the pressure will increase due to the conversion from the velocity to pressure due to the geometry of these several parts of the compressor. Okay, so there's the definition by itself of how velocity is converted into pressure comes from Bernoulli's equation, okay, and it's just related to the fact that the compressor is rotating, and the compressor therefore has an internal energy, has a very high energy, which is converted or is given or provided to the flow, and the flow becomes therefore highly pressured. Okay, so we just get the flow at a higher pressure due to the movement and velocity of the compressor itself. Now, mechanical work, okay, the rotation of the compressor, as we mentioned before, I think, is actually the result of the rotation, okay, of the turbine, which is located on the back, and because the turbine is moving, we actually have the compressor moving, and the fact that the compressor is moving actually allows for the fluid to be compressed, right? Okay, so there are several types of compressors, and mainly we will discuss axial compressors and centrifugal compressors. So the idea for axial compressors is that the flow will go parallel to the rotation axis. So you can imagine that the flow is actually, the rotating axis would be the center, right? This axis over here, because it is the compressor is rotating in regards to this axis, and the flow will therefore go parallel to the axis throughout the compressor. Now, this is these kind of compressors, the axial compressors, are actually very common in modern turbojets and turbofans, okay, also turbopropellers, because they're a very effective way to increasing a lot the pressure of the fluid, okay. Per each row, okay, we will actually be able to provide something like 1.15 to 1.6 times an increase of pressure. Okay, so this means that the pressure over here will be actually 1.5 times, for instance, the pressure over here. Okay, so multiply this by all the stages, and you have a pretty decent increase of the pressure. Right? We can actually link several stages. In fact, a lot of stages, and there are some new engines which I think they are up to 40 times. Okay, so in general terms, the pressure on the last one is actually 40 times bigger than the pressure at the beginning, which is a very high rate for pressure. Okay, as we mentioned before, the airflow goes in this direction. What we have is a rotating row. Okay, and this is actually translated into pressure by using a stationary vane row like this, okay, which will, you can see that the airflow is forced to rotate, and then it is forced to maintain some kind of steady direction, and then it is rotated again, okay, and this is continuous. You can do this, as we mentioned, for several stages, and in the end we get a very high pressure fluid. Okay, Apart from the axial compressors, which are the most common, I would say, in modern engines and specifically in commercial engines, we also have centrifugal compressors, which in fact the flow, instead of going parallel to the axis, right, it will actually move centrifugal. So it starts pretty close to the center of rotation, and due to the rotation of the compressor also, it will kind of move to the side, and this will give an increase of pressure, right? So it's also interesting to use centrifugal compressors. However, the main disadvantage is that due to the geometry, you can imagine that you can just use only one, okay? And using one, you may get a 4 times increase of pressure, but you can't get something like 40 times the amount of increase of pressure, okay? So this is the main distinctive fact between axial compressors and centrifugal compressors. Centrifugal compressors, you may find them in very or relatively small aircraft which don't demand that much compression, okay? Or you can also find it in RC, radio control aircraft, okay, and other kind of engines, but at least not for now, it's not that common, right? So commonly right now we have axial compressors. Okay, so as we mentioned before, axial compressors, what they do is rotating airfoil, okay, which will basically create difference in pressure, the same as the wing, similarly to the wing, okay, but by each stage we'll be able to actually increase the pressure a bit, and therefore the pressure will be very much increased. The fluid is parallel to the axis of rotation. There's a continuous flow of a compressed gas, okay, so the gas is at each stage it is compressed a bit more, and in general terms it has high efficiency, okay, and large mass flows. So it can cover a lot of mass flow in just one row like this, okay, and different stages. You can just have a lot of pressure, an increase of pressure which is very large, and also for large mass flows. In addition to that, as we mentioned before, we have several rows of airfoils, okay, and this is also combined to the fact that we have several compressors, lines of compressors. So each row, okay, each circle of these ones is actually composed by many airfoils, and these airfoils actually create some difference in pressure, as we mentioned, and because we have a lot, we are able to gather a lot of a high mass flow, okay, and we are able to pressurize this large mass flow throughout the flight of an aircraft. Okay, and in centrifugal compressors, as we mentioned before, what we have is a rotating compressor again. Air enters in the axis of rotation, okay, or in very close to the axis of rotation, but has a big radial component when exiting the compressor. So basically it will go in this direction, and then it will end up going in this direction almost, okay? So especially useful for high volumes but little pressure compression. So it is also useful for large mass flows, even more, okay? But the pressure given, as we saw before, is like 4 times and not 40 times. And this kind of compressors are actually very common in other industries. So specifically for industrial purposes, a lot of compressors are based on this kind of geometry, which is it's interesting because it's just simpler to design, it's simpler to maintain in general terms, okay, and it can be useful if you need just 4 times the amount of pressure, which is mostly enough for a lot of industrial purposes. But in the case of aircraft, we just need a very high compression in order to provide the maximum thrust possible, okay? So this would be all. We can go now to the next class.